Hi everyone, I'm Cheryl. In this problem, we're asked to use a double integral to find the area of the shaded region. So we know that the area can be found by using a double integral where we integrate over a region. We integrate dA. Now, this particular region is a cardioid, and it's going to be much easier to think of this in terms of polar coordinates. So that's what we're going to do. So I'll set up my double integral. If I'm using polar coordinates, dA is going to be r dr d theta. Now let's take a look at what those limits of integration need to be. Well, if I come over to my region, and again, I think of using a representative element, and I'm going to make it an r simple one, and look at the little pieces as I create that representative element. I will be going from 0 out to the edge of that cardioid, which can be represented by 1 plus cosine theta. So the inside limits of integration are going from 0 to 1 plus the cosine of theta. For the outside limits of integration, to use this particular representative element, I need to go the whole way around this cardioid, which means I'm going to be starting at 0 and going the whole way around. That takes me to 2 pi to get the entire cardioid in. So I'll be going from 0 to 2 pi. All right, now that I have my double integral set up, I can go ahead and start working on it. And as always, I'll start with the inside piece. Okay, so I have the integral from 0 to 2 pi. And starting on the inside, the integral of r dr, that will be r squared divided by 2. And I'll be evaluating that from 0 to 1 plus the cosine of theta. And then, of course, I still have my d theta for my outside integral. All right. Next, I need to plug in the upper limit of integration. So I still have 0 to 2 pi. And I'll have the quantity 1 plus cosine theta squared divided by 2. And then I have to subtract what happens when I plug a 0 in, but that's just 0. So I'm left with the quantity 1 plus cosine theta squared divided by 2 d theta. All right, now to do this integral, I think what I'm going to do is multiply out my quantity 1 plus cosine theta squared. So that's going to look like the integral from 0 to 2 pi of 1 plus 2 cosine theta plus cosine squared theta all over 2 d theta. All right, let's move this up here. The next thing I'm going to do is I'm going to go ahead and split this fraction and write the integral from 0 to 2 pi of 1/2 plus cosine theta plus 1/2 cosine squared theta d theta. Now the first two terms of that integral will be easy to do. However, I need a little more work with 1/2 cosine squared theta. I'm going to use one of my identities and rewrite this as the integral from 0 to 2 pi of 1/2 plus cosine theta plus 1/2 times, this is going to be 1 plus cosine of 2 theta divided by 2. That's a power reducing identity, d theta, which means I can write this as 1/2 plus cosine theta plus, this will be 1/4 plus 1/4 cosine 2 theta d theta. And I notice I have a couple of constant terms that can be combined. 0 to 2 pi. That will be 3/4 plus cosine theta plus 1/4 cosine 2 theta d theta. Okay, now that was quite a bit of simplifying, but at this point I'm ready to go ahead and do that outside integral. So when I integrate with respect to theta, I will have 3/4 theta plus the sine of theta plus 1/4. Now you will need a little u substitution here, but it's small enough I think I'll just do it in my head. So I'm going to have another 1/2 times the sine of 2 theta here. And then I have to evaluate all of that from 0 to 2 pi. All right, so as usual, I'll plug in the upper limit to begin with. So I have 3/4 times 2 pi. Then I'm going to add the sine of 2 pi, plus this will be 1/8 times the sine of 2 pi times 2, that'll be 4 pi. Then I need to subtract what happens when I plug 0 in. 3/4 times 0, that's just 0. The sine of 0 is also 0. And 2 times 0 is 0, so the sine of 0 is 0, and 1/8 times 0 is 0. So that last piece are all just zeros. So let's go through here, and I'm going to have 3 pi over 2. And as I said before, this term is 0, this term will also be 0, so my final answer for my area is 3 pi over 2 square units. I hope that was helpful. Thanks.